Okay, good morning, everyone. Thank you for coming along to our short session today. I'm Rachel Johnson, Vice President of Advanced Fuels at Urenco. And today, as the facilitators of this workshop, we would like to share a little bit about what we're doing to support the supply chain for advanced fuels. And then we would love to have this opportunity for two of our lovely customers to share some of their progress and challenges and opportunities that they've made so far. So without further ado, I'll introduce Magnus Mori, who's Head of Advanced Fuels at Urenco. Thanks, Magnus.
Thank you, Rachel. Good morning, everyone.
Morning.
I'll start my presentation with a question which is very philosophical. Why are we here? And we're here because of the enormous need for energy that we're all seeing around us. And I won't spend too much time talking about global growth or industrial expansion, all about this energy security, energy independence, climate commitments. What I want to talk about is the potential of nuclear to deliver on these needs. And in particular today, I want to focus on the potential for SMRs and AMRs to deliver on these needs. This is a quick summary of a study that will be published in 2 weeks that Urenco performed together with Lucid Catalyst. And the message here is that we have different scenarios. No matter what the scenario, the range of demand from SMRs, AMRs in the next 25 years goes from 7 gigawatts to 700 gigawatts, depending on what you're looking at. But even 7 gigawatts of demand would require, for instance, Urenco to double the size of its investments in advanced fuels. So no matter what the size of the challenge, we all need to roll up our sleeves and get to work. What is Urenco doing today, then, to deliver to this market? We operate 4 enrichment sites in 4 jurisdictions: the US, the Netherlands, Germany, and the United Kingdom. Our capacity today can deliver enough enrichment services for about 130, 150 nuclear reactors worldwide. And we're investing actively in advanced fuels. So as of today, our business is enrichment services up to 5%. By the end of the year, we'll do first delivery of enrichment services up to 10% out of our site in the US. Our site in the UK will start LEU Plus deliveries potentially from next year. And we're getting ready for HALEU. We have an investment in the UK for a HALEU plant that is being built today, that will be online in 2031, with a nominal capacity that can be up to 27 metric tons per year, and it's expandable. And it's happening. This is reinvestment, 50% from Urenco, 50% from the UK government to address the chicken and egg problem. And then more near term, as I said, LEU Plus. The NRC issued an operational license for us at the end of September, and we're now getting ready to make first production at our site in New Mexico. There are still some challenges in the advanced nuclear fuel cycle. This is what we see today. For the normal fuel cycle, for HALEU and advanced fuels, we still need to, and we are addressing questions about logistics, deconversions, fabrication at commercial scale. And for this, we're working together with our partners, with our customers, to address the issues and solve them together. So very quickly then, I'll mention a couple of highlights to introduce Radiant and Jimmy Energy, with whom we signed with Radiant the first HALEU commercial agreement. And with Jimmy, we signed last year an LEU Plus agreement to accelerate their deployment of their technology in France. Rita, the mic is yours.
All right. Great. Thank you. All right, great. Thank you, Magnus, for that introduction. Can you hear me okay in the back? All right, very good. So I'm Rita Baranwal. I am the Chief Nuclear Officer for Radiant. I'm really grateful to Urenco for this opportunity to talk to you today about who Radiant is and what we're doing. If you listened to Dr. Sama Bilbao-Leon's talk yesterday, she mentioned that we need to stop with the declarations and start with the doing. So I'm here to tell you about how Radiant is actually actively doing. So we're a team of over 100 employees. Oh my goodness, all right, here we go, I'll get out of the way. We're a team of over 100 employees. We are based in El Segundo, California, which is right next door to the LAX airport. We were founded by a former SpaceX engineer who reported straight to Elon Musk. So our roots are in aerospace, and our mission is to deliver microreactors to the world to help elevate everyone to a level of prosperity that many of us are in the world are accustomed to. We are pretty well funded. We have 225 million US in private capital, and then we have additional funding in government contracts, mainly from the United States. We just announced last month our factory for producing microreactors is going to be headquartered in Oak Ridge, Tennessee in the United States. It is a 350,000 square foot facility, and we start construction in January of next year, and we're hiring for that factory for employees to start working in the summer of next year. This was a really big deal in the state of Tennessee. We've had career fairs already, and students from high school on up are very interested in opportunities in working in this facility. So let's talk about actually the doing piece. Radiant is gearing up to deploy our reactors, starting with our first test, and I'll talk about that in a moment, next year. We were competitively selected to be the first reactor to test in the U.S. Department of Energy's Idaho National Labs DOME. DOME stands for the Demonstration of Microreactor Experiment. Magnus already talked about this, but I did not hear enough applause. The first commercial HALEU contract was signed with Urenco. Thank you. The reason why that's important is because it sends a signal that there is an actual market for HALEU. That we're not just talking about HALEU. There's not just chickens. We are starting to address the chicken and egg problem. So thank you to Urenco, and I'm really, really excited and proud to be part of that first that unlocks an identification to the HALEU market. We've also executed the first ever agreement to deploy mass manufactured reactors to Air Force bases in the United States. And then finally, we have executed agreements to deliver over 25 reactors to different companies. And this is more than just an MOU. These are deposits. So this is not just a handshake. It's not just an agreement. It's not just a press release. This is actual money changing hands here. You'll see at the bottom some of our funders. We're very, very grateful for their support. So this is kind of an overview of 4 of our reactors. We are aiming for rapid deployment. I'll get more into that in a moment. It is scalable, so you can have 1. You can have 1, you can have 2, you can have 4. It is going to be mass produced, so in that factory in Oak Ridge, Tennessee in the United States, we will be producing 50 reactors a year at the height of production. There is no on-site refueling. These reactors are designed for at least a 20-year life, and they go in between 5 years, up to 5 years in between refueling. You send the reactor back to our factory, we refuel it, we send it back to you for another 5 years. And it is passive, it is fail-safe. So I like to call this megawatt in a box. It can be shipped to you on a flatbed truck, by rail, or frankly by aircraft. We're getting the weight down so it can actually be transported on a C-17. It takes less than 2 days to install. It actually takes 1, but I want to be conservative here. It can be, as I mentioned, it's built in Oak Ridge, Tennessee, and then deployed anywhere around the world. 0 on-site waste. You tell us where you would like it deployed. We help with the permitting. There's very minimal land prep. There's no excavation. There's no construction required. And then it ships, as I mentioned, from the factory by land, sea, or air. It's nuclear, so it has all of the great facets of nuclear: clean, reliable, abundant, resilient. So this is a cartoon cutaway of what is inside that box. And it's a traditional high temperature gas reactor. We are using TRISO fuel. Thanks to Urenco, we will be able to have HALEU in that TRISO product. So here's the timeline. Here is the actual doing part. So I don't need to read all about it, but what I want to show you is that we aim to go critical. KDU stands for Kaleidos Demonstration Unit. We are targeting, we're on schedule to go critical before July 4th of next year, which is President Trump's line in the sand. He has said he wants reactors to go critical before Independence Day in the United States next year. We are on track to beat that. Our factory construction will be complete, and then we are delivering to our commercial, we're delivering commercial reactors to our customers right after. This image here in the back is that dome that I talked about. It might look familiar to some of you that are history buffs. That's the EBR-2 reactor that's been refurbished. And here's what it's going to look like when we put our test inside of dome. It will be a one-for-one replica of the reactors that we are commercializing, except for generating electricity. So everyone got a picture of that wanted one? Okay, because I'm gonna change slides in a second. The heat rejection system is outside of the dome only because of space constraints. Here's the doing. This was our passive cool-down test. These simulated all of our fueled monoliths. So we heated it up, we tested it. This was in September of 2024. This is our pride and joy. This is our reactor pressure vessel barrel that just arrived a couple weeks ago in-house at our facility in California. And you'll see a few shining faces that are in this picture that are in the back row over there as well. If you have questions, you can talk to some of my our supply chain leaders. All right, I talked about the heat rejection system that couldn't fit in the dome. That's it right there. So that's our heat rejection system. We are testing it at our facilities, in our facilities parking lot. It is literally being tested as I speak right now. And then once the test is complete, we will ship it out to Idaho National Lab to support the dome test that we are running. The team that you see here is part of the design review team that reviewed our design last week at our headquarters. And we intend to submit our preliminary safety design assessment to the regulator next week. So really working very quickly. It's a bit different than what I call the old stodgy nuclear industry is used to. I am grateful that things are changing in terms of pace, and we're moving with a sense of urgency. Thank you very much. Look forward to your questions, and I will close with Radiant. We are obsessed builders that will deliver the world's first mass-produced reactor. Thank you.
So good morning, everyone. So my turn. I have to be strong after Radiant. No, so I'm the co-founder and the CEO of Jimmy. So Jimmy is a French-based company. How do we define ourselves? Is we are supplier and producer of decarbonized heat for industry. When you talk about nuclear around you, everybody is talking about electricity. The fact is, when you look at what is the market and how it happens in my country, that is France, or in my continent, that is Europe, electricity, we have enough. The electricity consumption in France didn't increase for the last 20 years. So maybe we should do something else with the nuclear know-how that we have. And so based on that, that's what we started saying, okay, when we look at the energy consumption, in fact, industry is around 25% of the consumption. And when you look at the consumption of the industry, there is 75% of the energy that comes from heat. So why don't we use heat for this? Why don't we use nuclear to produce this heat? Because when you look at the clients, when you talk with the industry, what they say is that, okay, I can use something that is decarbonized, but it's always way more expensive than the fossil fuels that I use. So the goal that we have is say, okay, let's take the nuclear energy that we know how to make and make it something that is profitable in order to give to the clients something he wants. That means an energy that is decarbonized and at a cheap price. So that's what we did. We have worked for the past 4 years, 3 years, in order to design a reactor that does supply this kind of steam. And in fact, it's something that we know the cost because today we are at the edge of industrialization and we know all the cost of the device. We arrive at something that is an HTGR, a high temperature reactor. I will talk about it just later. And that is around 60 megawatt. It's a good power in order to have something that is profitable, but also small enough in order to go to the industrial sites. It is something that is quite small. It's 100 meters per 60 meters, so you can fit a lot of them in this kind of place. It's not a container. It's too hard to do a container. I'm sorry, but it's too hard. So we do something that is more a building, but in which you have something that is a 60 megawatt power and provide this steam that is decarbonized and cheap. In fact, it's not something that we have invented. It's something that the clients want. So we have sold the first clients, that is Crystal Union in France. We are under the licensing by the safety authority. So we have submitted the construction permit. That means we are really into the stuff, the complicated stuff about how the graphite behaves, how the nuclear fuel behaves, what happens if somebody comes with a truck with a full of explosives somewhere, this kind of stuff. And it's going quite well, so we're happy for that. And like you see, it's not very big. It's just here. It's really small on the site. So even if it's a building, you still have something that is quite small for an industrial site. So everything is quite fine. What we want to do is to commission it early 2031. We have, again, 2 years and a half, 3 years of licensing with the safety authority. It's the first time they see an HTGR on the French soil, so we have to bring everything for them, but it's going quite well. And then after, we have 2 years of building. It's quite a long time for the first one, but we hope we can decrease it after below the 3 years with regulation and construction. In fact, that means that if I'm a bit arrogant, I would say that we are the first SMR in Europe. We have the first under licensing. We have clients. We know where we are. We have contracts. And today, it's going quite well. We are under the support of the French government that has also continued this support this year. And if I have to say, we are the first private company to get the operator status as a nuclear operator in France. So for now, it's just a status. The goal is to make a nuclear reactor that starts. So if we talk about technical, it's a bit the same as Radiant in a way. It's something that is based on graphite. So graphite is a good thing because it is very it supports very high temperature. So that means that first the core cannot melt, and second point that you can bring very high temperature. It is something that has existed by the past. You have all the previous reactors, but the thing is, it never found its market. So at Jimmy's, what we did is just bring a market to a technology that already exists, and we choose some parameters, I will talk about it just later, in order to bring this thing that happens before to the way it should be used today. And if you look at it, so what we did is a small reactor. This is an HTGR, but we decrease a bit the temperature in order to get materials that are easy to get. And also, for another example, instead of having a steam generator, since we put the steam directly to the industrial process, we have a buffer loop that is based on CO2. So the goal is really to do something that is industrially proven, and that's fact we have the cost and every supplier for our system. And now, including Urenco, because I have to do, Urenco was a great partner and I have to promote them. But the thing is, we know where we are. In a way, we really have a connection everywhere in the world, so based on HTGR. And in a way, I want to thank Urenco because thanks to them, we have the uranium for the first core. Since we don't have the time to wait for 2031 for the LU, we started the 10% enrichment, but we count on them for the LU after because everything is better with LU in your life. And is it the last? I think it's the last slide. So you see. Thank you.
Thank you. Thank you to our brilliant speakers. If we could all move into the workshop room over here, we will open for questions for the next 25 minutes. So please, our speakers will be in there. Let's head on through. Thank you.